Hello, everybody. Mr. Wyatt here, and we are going to start topic 7.5 today, which is a whole bunch of geometry. And you might be thinking, well, 7.5, that's kind of weird. Well, we just finished topic 7, and the next topic, topic 8, that'll be coming up soon, but there is some more information we need to cover and show you all. And so we just figured since we're putting it between these two sections, between these two topics, we'll call it topic 7.5. So today we're talking about points, lines, segments, and rays. First of all, a point. A point is just a location, like a location in space. I mean, just we can represent it with a dot. Just kind of put a dot and say, well, there's my point. If I can get this to right, there's my point. And we label our points with capital letters. I can call this point A, for example. I could make another point. Maybe I'll put a point here. It's not writing for me again. There we go. I'll call that point C. And I could keep doing this, just keep placing points um, and represent them with just a little dot, okay? And use capital letters to label them. Now, a line is a series of points that extend in opposite directions without end. Okay, so it goes forever in two directions. You'll see lines shown with arrows, like here we have line CD. See how we have an arrow here, we have an arrow here. Those indicate that it will travel forever in both of those directions, and that line contains the points C and D. It's just a series of points that extend in opposite directions without end. Now, a ray, and this is kind of a weird concept, a ray is, you could think of it as being like half of a line. But a ray starts at a specific point and then it goes forever just in one direction. Instead of a line going in two directions, a ray starts at a point and just goes forever in one direction. Okay, and we can indicate the direction it's traveling using an arrow, kind of like you see here. This is ray EF, this is ray HG. Okay, so if a ray travels forever and a line travels forever in two directions, then I guess forever is half of forever? Mind blown. All right, anyway, so how do we name these different figures? Oh, one more I need to mention, a segment. A segment is a part of a line that has two distinct endpoints, and it includes all the points in between those 2 points. So here I have a segment, segment AB. If I want to name this figure, well, this is a segment, and what I would do is I'd put a bar over the letters AB, and I would say that's segment AB. I could also reverse those letters, and I could call this segment BA. It's just the segment that has points A and B for its endpoints, and it's all of the points in between them as well. All right, here I have a line. See the arrows? It's going forever in two directions. I can call this line CD. So I'm going to put CD, but this time I'll put a line symbol over it. Or I could reverse those letters and say line DC. It's the same thing. Okay, usually I like to go in alphabetical order, but it really doesn't matter. These I already labeled, it looks like. I have line, nope, now I'm looking at array. See how it starts at a specific point here? Point E, and then it travels forever to the right. We call this ray EF. See how the ray symbol is just a little arrow? So it starts at point E, it travels through point F, and continues on forever. Okay? Now look at this next ray. I don't call this ray GH, I call this ray HG. And when labeling it, I put HG and then the arrow is pointing above it. That's the ray symbol. And you might be thinking, but the ray isn't going to the right, it's going to the left. True, but when I write it down like this, I just know this is a ray. I know it starts at point H, it travels through point G, and then continues on forever. So here's my ray starting at H, traveling through G, and continuing on forever. Okay, so those are examples of rays and how to label them as well. Okay. All right, how many ways can you name this line? Well, I could name it a whole bunch of ways. In fact, I looked at this 1, 2, 3, 4, 5, 6, 7. Oh, there's so many ways I can name this line. Okay, well, all you need is to list 2 points that are on the line, like C and A, and put the line symbol over it. We have line CA here. Some people might call it line CE and just choose the points that are farthest apart um, for the points that are shown, at least on this line. It's an infinite number of points on this line. These are just the 5 that happen to be shown here. I can call it line BE. I can reverse the letters. I can call this line ED. Sometimes people will ask me, well, when I'm naming it, can I list more than just 2 points that are on the line? Well, you could. You could call it line CADBE, but that's a complete waste of time because you only need to state 2 of the points that are on the line when naming it. So you could call it line AE, line AD, line BC. There are all sorts of ways we can name that line. Now, let's talk about rays here a little bit more. And so I'm going to go ahead and erase what I have here and clear that out. And I'm going to use this little line tool. Maybe I'll make it orange. Orange seems like a nice color for me to use here. How many ways can you name? I'm sorry, what is ray AB? Ray AB starts at point A, travels through point B, and continues on forever. That's ray AB. Now, what's ray BA? Maybe I'll switch colors now. Go to purple. Ray BA would start at point B, but now it's going to travel through point A and continue on forever in the other direction. See, these two rays go in opposite directions from each other because the first point tells you where to begin. The second point says, hey, you're going to travel through that point as you move along. And maybe if I made these a little bit bigger, you'd be able to see them a little bit easier. There, that's better. And I'll do the same thing with this other one. Uh-oh. If it will let me, I don't want to waste too much time doing this because we have a lot of things to cover here today. Do you guys get the idea? Hopefully you do. There, I can make it a little bit bigger. Go that size right there. Okay, so here's ray AB. It starts at point A, travels through B, continues forever to the right. Ray BA, though, starts at point B, travels through point A, and continues forever to the left. So the next question I have for you is what points are on both of these rays? Well, both of these rays include point A. Both of these rays include point D. Both of these rays include point B. Okay? Point C is not on ray AB, but it is on ray BA. Do you see that? And I look at point E, that's on ray AB, but point E is not on ray BA. Okay? So what point is not on ray AB? Well, here's ray AB. Point C would not be on that ray. Okay? All right, so that's the difference between ray AB and ray BA. It's two totally different rays. They start at different points and they travel in opposite directions, but they do overlap here. Segment AB represents the portion that is overlapping. Segment AB is on both rays. Okay? All right, let's continue on here. Now, a plane, we have a lot of vocabulary today. A plane is a flat surface. Theoretically, it has no thickness to it, and it extends indefinitely in all directions. I always like to use a piece of paper to kind of give an idea of what a plane is. Here's my flat surface right here. This is my plane. And that's what's shown in orange on the screen here. I have plane A. Down here, I have plane B. On plane A, it has no thickness. It goes indefinitely in all directions. On plane A, I have two lines that happen to be parallel. Parallel lines are lines in the same plane which never intersect. They're always the same distance apart from each other. Okay, those are parallel lines. On plane B, I have a pair of lines that intersect. They are intersecting lines, meaning they cross at one point. And these two lines cross right here. They're on the same plane, these two lines, and they're intersecting right there at that point. Parallel lines never intersect. Okay? So that's what planes are. It's a flat surface that extends indefinitely in all directions. This is parallel lines, and these are intersecting lines. You need to know all of this vocabulary. All right, so parallel and intersecting. Streets, for example, if you go to Washington, D.C., you're going to see all of the streets are laid out like a grid. We have all the vertical streets are numbered. Like here's 9th Street, 10th Street, 11th, 12th, 13th, and so on. And if you go horizontally, you'll see they're labeled with letters. We have G Street, F Street, E, D, C. They're all laid out in a grid using parallel lines. That's pretty nice. It's a little easier to find your way around in Washington, D.C. than it is, for example, in Red Wing here, where they have to fit all the roads in between all the bluffs. Okay, so F Street and G Street are parallel to each other. I could kind of show that here. F Street is right here. G Street is right here. Oops. Oh boy, let me try it again. Here's, maybe it won't let me now. Turned off the little tool there. Here's G Street right here. You see how F and G streets run parallel? Now I can also see that 13th Street intersects both of these streets. So let's find 13th Street. Here's 13th Street, travels right along here. And it intersects both of those, both streets F and G. Okay, so we have parallel and we have intersecting streets in Washington, D.C. All right, one more term for us to discuss today, skew. Skew lines. Remember how parallel lines and intersecting lines are in the same plane? Imagine them being in the same plane. I could almost show two lines on this piece of paper, for example. You know, here I'll use these pens to show kind of represent my lines, you know. And I can show them as being parallel. I can show them as being intersecting, but they're on the same plane. Skew lines are not on the same plane. So in that top plane here, you see how we have one line that's on the plane running here horizontally, but then we have another line that's passing through, almost like it's just stabbing through, like there's a hole in the paper here that represents the plane. And these are skew lines. They do not cross each other. They kind of look like this. If I use these two pens representing my skew lines, one's traveling this way, one's going up, down. They're never going to intersect. They will never cross each other. But they also are not parallel to each other. They're not the same distance apart from each other at all points because they're not even in the same plane. This one's on a plane that goes vertically. This one's on a plane that goes more horizontally. They're on totally different planes. Those are called skew lines. All right? In both of these figures, you can see how I've drawn in some skew lines. They don't intersect, but they're also not parallel. They're not even on the same plane. Skew, that's what skew lines are. Okay? So if I'm looking at this house here, I'm going to look at number 2 here, a segment skew to segment AB. First of all, segment AB, let's find segment AB. Segment AB is right here. We start at A, go down to B. There's segment AB. If I want a segment that is skewed to that, imagine AB. It's going straight up and down. It's vertical here. I need to find one that will never, ever intersect it, but also isn't parallel to it. A good example of that would be like segment GH, the ridge line of this house. It will not intersect segment AB, but it's also not parallel to it. So it is skew to segment AB, segment GH. Okay? We're running low on time. So very quickly, if I want to find something parallel to segment AB, well, how about segment EF? That's parallel to it. Or segment DC. Oops, I'm messing with my picture there. Over here. All right, I'm about out of time, so I'll see you tomorrow.